8,000, 9,261, 10,648, 12,167, 13,824, 15,625. 8,000, 9,261, 10,648, 12,167, 13,824, 15,625. 8,000, 9,261, 10,648, 12,167, 13,824, 15,625. 15,625, 13,824, 12,167, 10,648, 9,261. 15,625, 17,576, 19,683, 21,952, 24,389, 27,000. 27,000, 24,389, 21,952, 19,683, 17,576. Now all 30, 1 to 30, forwards and backwards. 1, 8, 27, 64, 125, 216, 343, 512, 1,000, 1,331, 1,728, 2,197, 2,744, 3,375, 4,096, 4,913, 5,832, 6,859, 8,000. 9,261, 10,648, 12,167, 13,824, 15,625, 17,576, 19,683, 21,952, 24,389, 27,000. And descending. 27,000, 24,389, 21,952, 19,683, 17,576, 15,625, 13,824, 12,197, 10,648, 9,261, 8,000. 6,859, 5,832, 4,913, 4,096, 3,375, 2,744, 2,197, 1,728, 1,331, 1,000, 512, or rather 729, 512, 343, 216, 125, 64, 27, 8, 1. Alright, so we're going to put those to rest for a period of time, and instead focus on the factorials. One, 2, 6, 24, 120, 720, 5,040, 40,320, 362,880, 3,628,800. Now 11 factorial. 39,916,800. 11 factorial. 39,916,800. 11 factorial. 39,916,800. 39916,800. 39916,800. 39,916,800. 39916,800. 39,916,800. 479,001,600. 479,001,600. 479,001,600. 479,001,600. 12 factorial. 479,001,600. 12 factorial. 479,001,600. 479,001,600. 13 factorial. 6,227,020,800. 6,227,020,800. 6,227,027. 6,227,020,800. 6,227,020,800. 6,227,020,800. 39,916,800. 479,001,600. 39,916,800. 479,001,600. 39,916,800. 479,001,600. 6,227,020,800. 6,227,027,800. 6,227,020,800. 6,227,020,800. 6,227,020,800. Okay. 12 factorial. 479,001,600. 13 factorial. 6,227,020,800. 12 factorial. 479,001,600. 13 factorial. 6,227,020,800. Okay. All right. Now, this one, x to the 4 add x squared, y squared add y to the 4. I wanted to recall this. X to the 4 add x squared, x to the 4 add x squared, y squared add y to the 4. X squared add xy add y squared all times. X squared take xy at y squared. X to the 4 at x squared y squared. X to the 4 at x squared at y squared. X to the 4 at x squared y squared at y to the 4. X to the 4 at x squared y squared at x. Beg your pardon. Let's try saying it 3 times. X to the 4 at x squared y squared at y to the 4. X to the 4 at x squared y squared at y to the 4. X to the 4 at x squared y squared at y to the 4. X squared at xy at y squared all times. X squared take xy at y squared. X squared at xy at y squared all times. X squared take xy at y squared. X squared at xy at y squared all times. X squared take xy at y squared. That's x to the 4 at x squared 4. Alright, just computation now. A rectangle PQRS has the following coordinates of vertices P, Q, and R. P is 1, 1, Q is 7, 4, R is 5, 8. Now find S. We visualize that it is a rectangle mostly in the first quadrant, where P is positioned at 1, 1. Q is positioned 6 to the right and 3 up from P. And R is positioned 2 to the left and 4 up. 2 to the left and 4 up from Q. And now we have to find S. So we visualize the triangles involved. Quantities that we require. Six, 3, 2, 6, 3, 6, 3, 4, 2, 6, 3, 4, 2, 6, 2, 2, 4. So we need to go 2 to the left and 4 up to obtain S. We go 2 to the left and 4 up from 1, 1. That would be negative 1, 5, negative 1, 5. So you say to us that PQ is a rectangle and the coordinates of the vertices P, Q, and R are 1, 1 for P, 7, 4 for Q, and 5, 8 for R. And then you ask us where is S, and we say negative 1, 5. Find the total face value of 440 million £5 notes. We presume this just means multiply 440 million by 5, which would be 2,200,000,000 pounds. 2,200,000,000 pounds. You ask us to find the total face value of 440 million £5 notes, and we say 2,200,000,000 pounds. What is 1,020 claps per minute? In claps, we divide 1,020 by 60, which is 102 divided by 6, which is 51 divided by 3, which is 17. You ask us what is 1,020 claps per minute in claps per second, and we say 17. How many two-digit primes have only non-prime digits? Non-prime digits. The non-prime digits are 0, 1, 3, no, rather, the non-prime digits are 0, 1, 4, 6, 8, and 9. 0, 1, 4, 6, 8, and 9. They ask for 2 digits, so the first digit cannot be 0. So 1, 4, 6, 8, and 9. And then, how many two-digit primes have only non-prime digits? All right. So now we have to check through the 10s, the 40s, the 60s, the 80s, and the 90s. But in the units place, primes, two-digit primes can end in 1, 3, 7, or 9, but the only ones that are non-prime out of those are 1 and 9. So we say 11 and 19, followed by 41, and then 61, and then 89, and that's it. That's it. 11, 19, 41, 61, 89. So there are 5 of them. There are 5 of them. And we check. Everything must be checked. Correct, 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 correct. Okay, all correct. Very good. We move now to set 12. How many seconds are in 1/4 of 1/6 of 1/8 of a day? How many seconds are in 1/4 of 1/6 of 1/8 of a day? We could use the fact that there are 86,400 seconds in a day and then divide it by 8 times 6 times 4, but that's not a good way to do it. Instead, consider that 1/8 of a day is 3 hours. Rather, consider that 1/4 of 1/6 of a day is 1/24 of a day, which is 1 hour, and then 1/8 of an hour is 7.5 minutes. And how many seconds are in 7.5 minutes? The answer is 420 or 30, which is So you ask us, how many seconds are there in 1/4 of 1/6 of 1/8 of a day? And we say 450 seconds. Which of 3, 4, 5, 6, and 7 satisfies the following inequality? 3/10 is less than n/20, which is less than 2/5. 3/10 is 6/20, and 2/5 is 8/20. Now, what is between 6/20 and 8/20 and is also over 20? The answer is 7. So the answer is 7. You ask us which of the following 3, 4, 5, 6, and 7 satisfies the inequality. 3/10 is less than n/20, which is less than 2/5, and we say n is 7. Four consecutive integers sum to 2. Find the least of them. 4 consecutive integers sum to 2. Find the least of them. Okay, so because they are consecutive integers, let us call the least of them n. Then their algebraic form is n add 1, n add 2, n add 3. We put them together and we get 4n add 10, and 4n add 10 is equal to 2. Therefore, 4n is equal to -8. Therefore, n is equal to -8/4, which is -2. So you say to us that 4 consecutive integers sum to 2, and you ask us to find the least of them, and we say -2. How many of 15, 25, 45, 75, and 225 are factors of 2025? So 15 is obvious, as 3 and 5 make 15, and 3 and 5 go into 2025. 25 is also obvious, as it ends in 25. 45 is also obvious, as it's the square of 45 itself. 75, a little bit less obvious, but note that it's 25 times 3. 25 goes into 2025, and so does 3, and therefore 75 must as well. And lastly comes 225. Well, multiplied by 10, you get 2,250, then take 225, and you get 2,025. So the answer is all of them. So you ask us, how many of the following go into 2025, or how many of the following are factors of 2025, and you say 15, 25, 45, 75, and 225, and we say all of them. How many distinct cubes have 3 red and 3 blue faces? 3 red and 3 blue faces. All right. So the only possibilities are to either have the 3 red faces meet at a single vertex, as in the front, top, and right side of a Rubik's Cube that I'm holding in my hand, or to have the 3 red faces be the front, right, and left faces of a Rubik's Cube that I'm holding in my hand. So it would seem to be 2. However, just making sure here. Yes, for the first possibility that I announced, by rotation that seems to cover everything. I can always just make the sort of focus vertex of the 3 faces, as in the vertex that they all have in common. I can position it to be anywhere, so that seems to cover all of those. And for the latter one, yeah, I could rotate it such that front becomes top, rotating it that way such that it ends up covering all 4 possibilities in that way, as in left front right, left top right, left back right, left bottom right. And also I can rotate it such that front becomes right, covering all 4 possibilities that way, as in top front bottom, top right bottom, top back bottom, top left bottom. So 2 possibilities, 2. Which of 5, 7, 9, 11, and 13 is not the sum of 2 primes? Well, 5 is 2 add 3, 7 is 2 add 5, 9 is 2 add 7, 11, that's not going to work because you subtract 2 from it and you get 9, which is not prime. Then the only other primes are odd. But 13 is 2 add 11, so the answer is 4 of them. No, wait, you asked us which is not. That's very important. So you asked us which of the following is not the sum of 2 primes, and you say 5, 7, 9, 11, and 13, and we say 11. Find the remainder when 12,345 times 54,321 is divided by 9. All right. So How does it work again? I think you say that 1, 2, 3, 4, 5 divided by 9, and we look at the remainder of that. And the answer is 6. And then 5, 4, 3, 2, 1 divided by 9, and we consider the remainder of that. And the answer is 6. And so, wait, what do we do? This is so, all right, so, now 3 is a factor of 1, 2, 3, 4, 5, as it sums to a multiple of 3. And it's also a factor of 5, 4, 3, 2, 1, as it sums to a multiple of 3. And therefore their product must be divisible by 9, so the answer is 0. Yeah, you ask us, what is the remainder when 1, 2, 3, 4, 5 times 5, 4, 3, 2, 1 is divided by 9, and we say 0. All right, and then you ask us, how many squares are exactly 4 greater than a prime? How many squares are exactly 4 greater than a prime? All right, so n squared minus 4, we require that to be prime. Well, n squared minus 4 is n minus 2 times n plus 2. And is that a prime? Well, it would only be prime if n minus 2 is exactly 1. It would only be prime if n minus 2 is exactly 1. Or if you might say, or if n plus 2 is 1, but that's not true, because that would mean that n would be negative. Anyway, n minus 2 has to be exactly 1, so n has to be 3. So 3 take, because it's 3, take 2 times 3 plus 2, so 5. 5 is the only prime that is exactly 4 greater than a square. You ask us how many squares are exactly 4 greater than a prime, and we say one of them, namely 5. All right, so there's some typographic issues with this. I'm not actually sure what overlining the digits means in this context because they're not decimals. Nonetheless, we give it a shot. Distinct digits satisfy distinct digits x, y, z satisfy x at x at y at y equals z z z. Find x at y at z. All right, so because z z z is 3 digits, we've added a pair of single digits to a 2-digit. The only way that's possible to get a 3-digit is if z is 1. So z must be 111. Z must be 111, and on the left hand side we have an even plus an odd. Rather, we have an even plus something equaling an odd. We get an even from the two x's combined together. And therefore, y must be odd. Y must be odd. So if y is 9, then x must be 6. And if y is 7, then there is no x which satisfies it. So we believe that x, y, and z are 6, 9, and 1 respectively, and their sum is 16. So you ask us for x, y, and z being distinct digits, and if we know that x plus y, y equals x, y, z, or rather, let me begin again. For x, y, and z, which are distinct digits, if we tell you that x plus y, y equals z, 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 then what is x at y at z? We say 16 because we say that x is 6, y is 9, and z is 1. How many 2-digit squares have a square digit product? We only have to check from 4 squared to 9 squared, which is really not that hard. So 4 squared fails, 5 squared fails as well, 6 squared, that fails, 7 squared, that passes, 8 squared, that fails, and 9 squared, that fails. So the answer is exactly 1, namely 6. And now we check. Okay. $14. All right. Yes, that's correct. All right, all good except problem 113. Four consecutive integers sum to 2. Find the least of them. Call the least of them x. Then they follow the pattern x, x at 1, x at 2, x at 3. Their sum is 4x at 6, so we can detect the error now because we said 4x at 10, didn't we? Now if 4x at 6 is equal to 2, then 4x is equal to -4 and x is equal to -1, and so we found it and corrected it. All right, so set 13 now. Set 13. Which of 200, 300, 400, 500, 600 is a multiple of 24? Well, okay, so 600 is 600 is because you have to multiply by 25, but let's see now. 200, definitely not. 300, oh, beg your pardon, 300. 2 to the 4 times 3. It is. In what way? It is not. 400. No. 500. No. Only 600. Only 600. You ask us which of 200, 300, 400, 500, 600 is a multiple of 24, and we say only 600. The product 9 times 11 times 13 times 15 times 17 is a 6-digit number. 3N8185. Find N. Okay, so of course it has to be a multiple of 9 when you add them up. 3N8185. The sum of 3, 8, 1, 8, and 5 is 25. And so N is either 2 or, well, 11, but that doesn't work. So we believe that N is just simply 2. So you say to us that the product 9 times 11 times 13 times 15 times 17 generates a 6-digit number 3N8185, and you ask us to find N, and we say 2. Find the sum of 20% of 40% of 60 and 40% of 60% of 80. 20% of 40% of 60 is 20% of 24, which is 4.8. 40% of 60% of 80 is 40% of 48. 40% of 48, right? Right. Which is 19.2. 19.2 at 4.8, 24. 24. You ask us to find the sum of 20% of 40% of 60 and 40% of 60% of 80, and we say 24. What percentage of a 1 to 4 cordial to water mix is cordial? We say 20%. What percentage of a 1 to 4 cordial to water mix is cordial? We say 20%. Distinct digits A, B, and C satisfy ABC plus ACB equals C4A. Find their sum. Okay, so ABC at ACB is C4A. I add a pair of 3-digit numbers and I get another 3-digit number. So that restricts A. A has to be 1, 2, 3, or 4. 1, 2, 3, or 4. 1, 2, 3, or 4. Did you say that they were distinct? I don't think you said that. I'll just assume they're distinct for now, okay? Right, so if it's 1, then C is... No, that's not true. You're making a false conclusion about that. ABC at ACB. ABC at ACB, C. B at C is equal to A. B at C, the last digit is equal to A. Alright, so can you please hurry up? Alright, so just give me a second here. There must be something that I'm just not seeing here, and it's kind of... Did you say distinct? Yes, you did. Distinct digits ABC satisfy ABC at ABC plus ACB equals C4A. Find their sum. 1. If A is 1. What if you are 4? What if you are 4? Well, if you are 4, then then A is 4, and that's not possible. No, it is possible. Okay. No, it's not possible. It's not possible. No, I can see it because 400 whatever equals 44 on the end, so they have to be... No, that's not right. You're not thinking about it right. Okay, so 431 and 413. Because you have 800 right there, and you have C, but you don't have C right there, so notice that would produce a carry. That would produce a carry, right? You can't produce it. Okay. Darn it. Distinct digits ABC satisfy ABC plus ACB plus equals C4A. So find their sum. Find their sum. All right, so potentially all right, so multiple of 11, of course. Yeah, multiple of 11. Kind of stuck on that one. All right, we'll come back to it, no problem at all. In fact, it's getting a little bit late now. Which of the following is closest to 1? 7 over 8, 8 over 7, 9 over 10, 10 over 11, or 11 over 10? Okay. So what we're going to do is we're going to think, and we're going to drop the ones that clearly fail. So 9 over 10 versus 10 over 9. No, rather 10 over 11 versus 11 over 10. 11 over 10 is 1.1. No, better way to think about it. 10 over 11 is 1/11th distant, whereas 11 over 10 is 1/10th distant, and therefore 10 over 11 is closer. So we drop 11 over 10. Likewise, on the left-hand side, 7 over 8 versus 8 over 7. Well, 7 over 8 is 1/8th distant, and 8 over 7 is 1/7th distant. So 7 over 8 is the winner. And we drop 8 over 7. So now we compare 7 over 8 and wait, is that right? How is that in the wrong order? 7 over 8 is the winner on the left. And who's the winner on the right? The one that is 1/11th away. Right? Yeah, so 10 over 11. So now it's 7 over 8 versus 10 over 11. Okay, so who's closer? The one that is 1/8 away or the one that is 1/11th away? Obviously 10 over 11. And now we have the anomaly in the middle. 9 over 10. But that's 1/10 away. That's 1/10 away. So the answer is just 10 over 11. So you ask us which of the following is closest to 1, and you say 7 over 8, or 8 over 7, or 9 over 10, or 10 over 11, or 11 over 10. And we say 10 over 11, because it's 1/11th away. How many 3-digit numbers increase by 99 when their digits are reversed? When their digits are reversed. Okay, so (102) and 201. (203) and 302. 102, then 203, and 304, and 405. Just 4 of them. 102, 203, 304, and 405. Find the remainder when the sum of the first 10 factorials is divided by 5. All the factorials after 4 factorial end in a 0. And since finding the remainder when dividing by 5 is determined entirely to only add the first 4 factorials. So that's 1 plus 2 plus 6, 4, which in total makes 33. So it will end in a 3, and therefore the answer is 3. Wait, I forgot to tell you that in problem 27 you asked us how many 3-digit numbers increase by 99 when they are reversed, and we say only 4 of them. And then you asked me, what's the remainder when I add the first 10 factorials and divide by 5, and I say 3. The 7-digit number 193391A is a multiple of 6. Find A. We simply require it to be even and for the digits to add up to a multiple of 3. One nine three three nine one. Those add up to 26. If we make a 1, that satisfies the 3 test but fails the evens test. If we make a 4, it satisfies the evens test and the 3's test. Making a 7 to take the digit total from 26 to 33 would pass the 3 test but fail the evens test, and that's it. So A is 4. So you say to us that a 7-digit number 193391A is a multiple of 6, and you ask us to find A, and we say that A is 4. Which of 6 cubed, 8 cubed, 10 cubed, 12 cubed, and 12 to the 9 is equal to 3 cubed, at 4 cubed, at 5 cubed? Now, by simple computation, we know that 3 cubed at 4 cubed at 5 cubed is 27 at 64 at 125, which is, let's see, 27 at 64 at 125. Well, that would be 216, which is 6 cubed. So you asked us, which of 6 cubed, 8 cubed, 10 cubed, 12 cubed, and 12 to the 9 is 3 cubed at 4 cubed at 5 cubed, and we say 6 cubed. Now, we're not going to check for problem 25 because we actually find it kind of fascinating that for 3 distinct digits, A, B, and C, ABC adds ACB is equal to C4A, and then you ask us to find the sum. So we genuinely find that fascinating, and we're not going to check. And also, it's actually time.